Yaskawa.
Welcome to this Yaskawa Technical Training Services video that will demonstrate how to use Yaskawa's Harmonics Estimator software tool. In this video, we will show you how to input your customer's information and system particulars, add and edit the different motor systems that need analysis, and then review the results and generate a harmonic estimation report that you can pass on to your customer. This is the home screen to the Harmonics Estimator software. From here you can start a new project, open a previous project, or return to the active project. Once we start a new project, a splash screen appears that tells us that there are 6 steps to creating a harmonics estimation report. Step 1 is to enter our project and customer information. As well as entering information about the customer for which the harmonics estimation report is intended for, we can also edit our own information. This information will show up on the final report and includes a company address and a prepared by name. We also have the ability to attach a custom logo to the report, which will show up on the final harmonics estimation report. To attach a custom logo, click the View Select Company Logo button. When the pop-up window appears, click the Select File button to browse to your JPEG. In this case, we've already pre-selected our company logo, so we don't have to browse. We will just click OK to select. We are now finished with Step 1. It's time to proceed to Step 2, Utility Information. We can begin the utility information step by inputting the customer's utility company. Next, we need to specify to the software particular size information about the transformers that serve as our points of common coupling. The points of common coupling, or PCCs for short, are where many different loads come together and where the effects of harmonic load can be assessed. One PCC is at the utilities transformer and serves the whole building, and the second is internal to the building and is owned by the user. Size information for the transformers is in terms of kVA, secondary voltage, and percent impedance, or the kVA can be replaced with the short circuit current rating of the transformer. If the harmonics at the utility transformer is not of concern, PCC1 can be unchecked, and only PCC2, the user's transformer, is part of the analysis. Step number 3 allows us to define our different motor systems. We can add multiple different system types, or we can return to this step later and modify an existing system to test different configurations. At this point, we'll click the Add System button to begin adding motors and motor controls. When any system is added to the harmonic analysis, there is the ability to identify each system with its own system identification. Each system of our example is being fed from the same PCC2 transformer. We will have the ability to specify how much linear load horsepower there is, how much A1000 controlled horsepower there is, and finally how much U1000 matrix horsepower there is. We will begin by making our first system be a 75 horsepower across-the-line motor with starter. The software will assume a typical 0.88 power factor for the motor. It is a single motor, so we will leave the quantity at 1 and click Add System. With our linear load system added, we can proceed to add another load system. This second system will be A1000 drive-based systems. Once we select that our system will be A1000 based, we will need to further specify whether it will be a 6-pulse, 12-pulse, or 18-pulse configuration, and whether there are any DC bus reactors or AC line reactors involved. The A1000 based systems will also be 75 horsepower. Unlike the across-the-line motor of the first system, we will change the quantity to 2 and add 2 6-pulse, 75 horsepower A1000 drives and motors as our second system. For our third and final system, we will select one of Yaskawa's U1000 matrix drives to control a 50 horsepower motor. Notice that after we update the horsepower value, the software changes the power factor to a value more typical for the new motor size. Now it's time for a quick review. The navigation tree on the left allows us to select any of our 3 systems, and the tabs on the right show system data, harmonic contribution, and harmonic data in graph form for each of the systems individually. This segues into step 4, which is a system overview. All 3 systems we input are shown in red. Of note is that the 6-pulse A1000 driven motors are listed in the 6-pulse with DC link choke column, even though we never selected that option. This is because the software knows that size A1000 drive comes with a built-in reactor. When we are satisfied with the overview, we can continue on. Step 5 is the harmonics estimation for the total system. For our example is for all 3 systems, the linear, the 6-pulse A1000, and the U1000 combined. Some of the information on this tab is information straight from our Utility Information tab. However, there is some new data that has been estimated and displayed for us. According to the total system harmonic estimation, our current selection would not allow us to meet IEEE 519 at either point of common coupling. Since both the across-the-line motor and the U1000 driven motor add near negligible harmonic content, it must be the 150 horsepower of 6-pulse A1000 driven motors that are pushing us over the limit. Let's go back and see if we can edit our system to pull us into compliance. To edit our system, select the 6-pulse load system and click the Edit System button. Let's change our two 75 horsepower A1000s to a 12-pulse configuration. This should lower the harmonics generated by each drive. Click the Update System button and then return on to step 4 to see the 150 horsepower A1000 in the 12-pulse column. To check if we were successful, we can return to step 5, the Overall System Harmonic Estimation tab. According to the software, we should now be in compliance since our estimated total current demand distortion is at 7.8%, which is well below the 15% necessary to meet IEEE 519 for this system. There is a button on the Step 5 tab to access the graphed harmonic estimation for the total system at both points of common coupling. These graphs are also available in our final report. The final step, Step 6, is where we generate a harmonics estimation report. Our report layout is selectable on the right side of the last tab page. The report can be a full report with all available data and graphs, or it can just be a summary page. Once we have selected our report layout, we can preview the report by clicking the link View Harmonics Estimator Report. The report contains all of the data we have input into the software so far, including logos, addresses, and utility information. Besides showing the harmonic summary for the whole system as well as the graphs for both points of common coupling, our selected report also contains information and graphs for each individual system we added, as well as their graphs. Once you are satisfied with the report's contents, you can close the preview window. Our final demonstration regards emailing the whole report to the customer. Simply click the Email Harmonics Estimation Report, and if the software recognizes your computer's email program like Outlook, it will create an email message with the PDF of the report already attached. This concludes our review of Yaskawa's harmonic estimation software tool. I did not cover every possibility of the software, but I hope I gave you a preview of its capabilities. If you have any questions regarding this or any other Yaskawa product, please feel free to contact us.